Hello students, welcome to Physics Live channel. Today we are discussing a problem that is a photon of wavelength lambda is incident on a free electron at rest and scattered in the backward direction. The fractional shift in its wavelength in terms of Compton wavelength lambda c of the electron. So we know what do you mean by Compton effect, that is in a photon which is scattered by a electron and electron which recoils at an angle theta, and there is a phi angle in which the photon may be scattered. The scattering angle is phi. So here in this question, similar condition, that is a photon of wavelength lambda is incident on a free electron at rest, and the photon which is scattered in a backward direction means the phi should be, the backward direction means the photon comes like this, so phi should be pi. The scattering angle is pi. The fractional shift in its wavelength in terms of Compton wavelength lambda c of electron means, you know the Compton effect equation, that is delta lambda is equal to h by m0 c into 1 minus cos phi, that is lambda dash minus lambda is equal to h by m0 c into 1 minus cos phi. The h by m0 c, it is known as Compton wavelength lambda c. So in question, what is the fractional shift? Fractional shift means lambda dash minus lambda divided by lambda, that is h by m0 c, that is lambda c. 1 minus cos phi, here phi is pi, cos pi is minus 1, so 1 minus 1, that is 2 divided by lambda. So the fractional shift in wavelength, that is 2 lambda c divided by lambda. Okay, so this is the answer. Okay, so you should remember the basic equation in Compton effect. In Compton effect, we know that the wavelength of the incident photon increases after the scattering, that is energy decreases for the photon, so that is lambda dash is greater than lambda. So there is a shift in wavelength, that is there is a decrease in energy of the photon by hitting the electron. Okay, so electron is recoils and photon is scattered. So here we should know the basic equation, that is delta lambda is equal to h by m0 c into 1 minus cos phi, and we know the Compton wavelength, that is lambda c is equal to h by m0 c. Okay, we can find the value, that is h is equal to 6.626 into 10 raised to minus 34, and we put the mass of electron, and c is the velocity of light, so we get the Compton wavelength as 2.42 into 10 raised to minus 12. Okay, so thank you for watching.